Paris. The last days of February 1896. Henri Becquerel is frustrated. Days of overcast skies have ruined his experiment. He wraps a photographic plate in black paper, places a cross-shaped sample of uranium salt on top, and shoves the entire thing into a dark drawer. He expects nothing. Days later, on a whim, he develops the plate. Instead of a faint shadow or blank image, the plate is heavily fogged, as if it had been exposed to bright light. But the drawer was dark. The uranium had been emitting something invisible, all on its own, with no sunlight needed. That accidental discovery was the first hint that matter could spontaneously emit energy. It would lead to Marie Curie, atomic bombs, nuclear power plants, and cancer therapy, all because of bad weather and a failed experiment. To understand why this was so shocking, you have to understand what Becquerel was actually trying to do. In November of 1895, Wilhelm Röntgen discovered X-rays. They were invisible, penetrated matter, and fogged photographic plates. Scientists everywhere started hunting for other sources of the strange radiation. Becquerel thought phosphorescent materials might be a candidate. Phosphorescence is the glow that persists after a substance has been exposed to light. The idea was simple. Sunlight energizes the salts, and they then emit X-rays. His experiment was designed to test that. He would expose uranium salts to bright sunlight, then place them on a wrapped plate. If the salts fogged the plate, that meant they had emitted penetrating radiation. No sunlight meant no phosphorescence, meant a blank plate. The logic was airtight. The weather disagreed. The clouds over Paris refused to break. Becquerel couldn't expose his salts to sunlight, so he stored the prepared plate and the uranium cross in a drawer, intending to wait. Days passed. Still no sun. Finally, on either the 1st or 2nd of March, he decided to develop the plate anyway. He expected at most a very faint image from residual phosphorescence. What he got was a sharp, intense silhouette of the cross. The plate was heavily darkened. This wasn't residual glow. This was radiation as strong as if the uranium had been exposed to direct light, yet it had been sitting in complete darkness. Becquerel ran more tests. They tried uranium compounds that were not phosphorescent. They still fogged the plate. He tried uranium compounds that had never been exposed to light. They still fogged the plate. The emission didn't depend on sunlight. It didn't depend on any external energy source. It was a property of the uranium itself. Matter was radiating energy, spontaneously. Physics had no explanation for that. In his first paper to the Academy of Sciences, Becquerel was careful. He called it a new kind of invisible radiation. He didn't yet know what it was, but he knew one thing for certain. It was not phosphorescence. It was something else. The mystery attracted a young doctoral student named Maria Skłodowska. Marie Curie. She and her husband Pierre began investigating. They tested every known element and mineral they could get their hands on. They measured the radiation with an electrometer Pierre had built. They found that uranium was not unique. Thorium emitted the same kind of rays, and certain uranium ores, like pitchblended, were far more radioactive than pure uranium. That suggested the presence of something else, something much more active. They processed tons of pitchblende in a shed using acid baths and hand stirring. From tons, they extracted fractions of a gram. In 1898, they announced two new elements: polonium, named for Marie's homeland, and radium. Radium glowed with its own light, a constant, self-sustaining heat. Marie coined a term for the phenomenon: radioactivity. It was a force that came from inside the atom. Within months, medicine seized on radium's potential. X-rays were already being used to see inside the body. Radium promised to attack tumors. Doctors placed radium sources directly on cancers, believing it would burn away disease, and it did sometimes. But radiation burns also appeared on the hands of the doctors. Marie Curie herself suffered from chronic fatigue, cataracts, and eventually leukemia. The same invisible rays that could heal could also destroy. The energy could heal and destroy in equal measure. But nobody yet understood how much energy the atom truly contained. Unlocking the atom's full power took decades of discovery. Ernest Rutherford dissected radioactivity into alpha and beta particles. In 1911, his gold foil experiment revealed the atomic nucleus, a dense charged core. In 1919, he achieved the first artificial nuclear transmutation, turning nitrogen into oxygen. The nucleus was no longer an immutable speck. It could be altered. Physicists began to probe it with neutrons, discovered by James Chadwick in 1932. Then, in 1938, Otto Hahn and Fritz Strassmann bombarded uranium with neutrons and got barium, a much lighter element. The uranium nucleus had split. Lise Meitner and Otto Frisch correctly interpreted this as nuclear fission and calculated the vast energy release. That insight led to the realization of a chain reaction, which in turn led to the Manhattan Project and the atomic bomb. That same force heals cancer and annihilates cities, all born from a cloud. All of it started in a dark drawer on a cloudy day in Paris, when a failed experiment revealed the secret energy hidden in matter.